we shall continue with where we last finished. So we were discussing about the production of syngas. Syngas basically it is like a fuel produced by the pyrolysis or the gasification of municipal solid waste. So this can be used as a fuel as we discussed in our last session. So first here we'll be discussing about a fuel as a fuel in combustion engine. So it is very much similar to that of a natural gas. Like the natural gas is also being used as a fuel in a internal combustion engine. So similarly, the this syngas that can also be used there. So this combustion engine that is being mechanically coupled with a synchronous generator, and the output that is being the output that is electricity that is obtained from the synchronous generator. So here along with the generator and the combustion engine, there's a voltage regulator and a governor. So why we use both of these components? So the voltage regulator basically it is controlling the field excitation of the synchronous generator because it directly uh, uh, controls the output voltage. So whatever the voltage we are getting from the generated output electricity that is controlled by using the voltage regulator. So another thing which is shown here that is a speed governor. So why do we need it? Because of a mismatch between the load and the power generated, this power demand by the load and the power generated by the generator or our system, the generation system complete. So if there is a mismatch, then there is directly a change in the system frequency. So if the power generated that increases or that is higher or the load that reduces, means generation that is higher than the power demand, that causes an increase in the system frequency the and in case when there is a decrease or increase in the load, means the power demand that is higher than the power generation, so that causes a decrease in the system frequency. So means any type of change in the power generation and the power demand, okay, like the load that increases then the system frequency decreases, and if the load decreases the system frequency increases. So we have to correspondingly we have to, so as to maintain the system frequency constant, we have to correspondingly we have to change the generation. Okay, like the load is decreasing, we have to change the decrease. We have to change that is changes in the form of decrease in the power generation. So how we can do that? We can reduce the fuel supply to the combustion engine. Because how it has been done? By using this governor. So the fuel which is being supplied, fuel here that is the syngas, it is being supplied to the combustion engine, and we can control it. The controller, the governor that can supply less fuel to the combustion engine. So correspondingly, the power generated, which is by the generator, which has been mechanically coupled by this combustion engine, that will also decrease. Similarly, if there is a increase in the load, correspondingly the change in the frequency that will cause the governor to change the output or the fuel supplied to the combustion engine, so that the change in the generated output that corresponds, that matches the power demand. Because so in this way the system frequency that is also maintained constant. So this complete system here that is using syngas which is being generated by municipal solid waste. So it is basically serving two problems here. As I discussed in my first lecture on the same in the same topic of municipal solid waste, first of all it addresses the waste management problem. Next, it also addresses the electricity requirement, the power generation. The two type of outputs which we are getting here from this type of generation system. Also the municipal solid waste, that is a renewable source. Because here we are getting energy or the electricity being generated using renewable sources or the renewable resources. Okay, so I shall stop here.